We've seen how to convert an integer decimal base 10 number to binary using the iterative division algorithm. But what if the base 10 number is less than a whole number, i.e. something like 0.375 in decimal? So how would we convert a number like this to binary? Sometimes our general language is we would say this is a decimal number, but just to avoid confusion, I'm going to call this a floating point number instead of a decimal number, because in the context of this class we're using the word decimal for base 10 exclusively. So I'm going to call this a floating point number, or a fractional number. So the way we convert numbers like this to binary, we're going to use a method that I call it the times 2 method. And here's the idea. So we're going to do successive multiplications by 2. Do successive multiplications by 2. And then what we're going to do is we're going to strip off the result to the left of the decimal. Okay, so the result of taking our number multiplying by 2 to the left of the decimal, it's either going to be a 0 or a 1. We're going to strip that off and we're going to keep it. And then what we're going to do is we're going to continue until the result on the right meets one of 2 stopping conditions. Continue until result on right of the decimal point is either, it doesn't have to be both, just either 0, or you find a repetition. Okay, so we have 2 stopping conditions for our algorithm. And if one of them is true, we know we're finished. Not both of them need to be true, just either one is fine. Okay, so let me show you an example of what I mean by this method. So let's go ahead and do our example we introduced above. Let's convert 0.375 from decimal to binary. Okay, so what we're going to do is we're going to just take this guy and we're going to multiply by 2. So 2 times 0.375, that's going to give us 0.75. Okay, so then what we're going to do is we're going to strip this off and we're going to use it later. We take this and we multiply this 0.75 by 2. So 2 times 0.75 gives us 1.5. Now we're going to strip off this result to the left of the decimal. We're going to take this 0.5 and the 0.5 we're going to multiply by 2. So 2 times 0.5 gives us 1.0. Now the result to the right of our decimal point is 0. So that means we met the first stopping condition. Okay, so at this point we're going to collect the whole number results from top to bottom. Collect the whole number results from top to bottom. Okay, so how I have written out my multiplication here, the first whole number result from my first multiplication by 2 is this 0. So I'm going to take that 0. The next result is this 1, so I'm going to take that 1. And the next result is this 1. So this goes to the right of my decimal point, and this actually ends up being my solution. So I'll say, therefore, 0.375 in decimal is equivalent to 0.011 in decimal. Okay, so what if the base 10 number we want to convert is a mixed number. So it's larger than 1, but also has a fractional component. So let's do a second example. Suppose we want to convert 23.15 from decimal to binary. Okay, so the last example we did, we didn't have a whole number component, we only had a fractional component less than 1, but now we've got a part that's larger than 1, and we've got a part that's smaller than 1. So we're actually going to take this number and we're going to split it up into two parts. Okay, so I'm going to take this guy and I'm going to split the 23 off, and I'm going to handle this differently. Then I'm going to take the 0.15 and I'm going to split this apart, and I'm going to do this as a separate problem. Okay, so if I'm going to handle the 23 by itself. And the way I'm going to do this is the same way we did before. So if we have a whole number and we want to go from decimal to binary, we use that iterative division algorithm. So I take my 23, I divide by 2, that gives me 11 with a remainder 1. I take 11 and I divide by 2, that gives me 5 with a remainder of 1. And then I take my 5 divided by 2, and that gives me 2 with a remainder 1. I take my 2 divided by 2, that gives me 1 with a remainder of 0. Then I take that 1 and divide by 2, and that gives me 0 with a remainder of 1. And then I collected all my remainders from bottom to top. So it went 1, 0, 1, 1, 1. So this is the conversion of 23. So I handled the first half of the problem. Now what I'm going to do is this fractional part, I'm going to use that times 2 method to convert this fractional part. So just like the example we did before, now this part of the problem is going to be, we're going to handle the 0.15 using the times 2 method. Okay, so we take 2 times 0.15, and that gives us 0.3. I'm going to take this 0.3 and multiply that by 2, and that gives me 0.6. I'm going to take the 0.6 and multiply that by 2, and that gives me 1.2. I'm going to take the 0.2 and multiply by 2, and that gives me 0.4. Then I'm going to take the 0.4 and multiply that by 2, and that gives me 0.8. I'm going to take the 0.8 and multiply by 2, and that gives me 1.6. Okay, so as you see, just like I did in the previous example, every time I had a result, oops, that should be a 3, I took this result and I multiplied by 2. I strip this off, I only take what's to the right of the decimal and I multiply it by 2. I take what's to the right of the decimal, multiply by 2. So this is what I'm doing each successive multiplication. Now this column here of all these 0 and 1 results that are to the right of the decimal place, these I'm going to collect from top to bottom. So in this method we collect the remainders from bottom to top. This method we collect the whole number results from top to bottom. So that's going to give me, I put my decimal, then I get 0, 0, 1, 0, 0, 1. So why did I stop right here? As you'll see, this 6 we've actually seen before, right? So this is when we start to notice a repeat. This is actually going to be a repeated decimal. So this is the second stopping condition. When you see a repeated number, you know that you can stop. So we split the problem into two parts. Now we're going to put it back together. So therefore, 23.15 in decimal is equivalent to, the conversion of 23 into binary is 10111, and the decimal is 001 repeating. And this is the conversion to binary.